Good afternoon, everybody. Today, we're going to talk about problem number 3 of USACO Platinum Level 2022 December contest. The problem is like this. So Farmer John has a set of cows, right? And then they lined up from 1 to n. N is 7,500. So then he wants to, there's two types of cows here, G and H, right? Remember, we always have those two types of cows. And he wants to line it up so that it is, the whole line is palindrome, right? So it is not always the case. So he wants to move the cows by swapping two cows, adding two cows. The question is, for all the possible combinations of a sequence, right? That they want to take photos. It's a continuous subsequence, right? So there's n times n plus 1 minus 2 of those group. What is the minimum swap that Farmer John need to do for those cows in order to make it a palindrome? If it's not possible, then do -1, make a -1. So the question is, what is the sum of all those swap? Right. So here we give an example. If we have something like this, if it's G, of course, is palindrome, right? If it's GH, that's -1. You cannot do it. It's GHH, that's okay. If you swap between G and H, make HGH, then it's okay. Then GHHG, that's already a palindrome. So that's already good. So how do we solve this problem? First of all, N is 7,500, right? That immediately tells us is the worst is n squared log n complexity. That's what we need, right? So that's a worst case scenario. Think about like this. If you have a subsequence, any subsequence, okay? So you have a bunch of G's and you have a bunch of H, a bunch of H and a bunch of G. So let's say you have a bunch of H here, maybe a bunch of H here. We are talking about minimum movement, and we're talking about palindrome, right? Means this, the one, let's look at the H, the one closer to the left side of H should match up to the one closer to the right side of H, right? Because if you match, for example, if you match up to here, then you have to move this edge, somehow swap it to make it there. That doesn't make sense, right? It's not the minimum movement anymore. So it has to be the one on this side, most to the left side should match up the one to most right-hand side. No edge should jump over another edge. Okay, and if you have, let's say if you have a pair of edge, let's say from here to here, okay, that's a pair. If you want to make it a palindrome, so obviously you want to make the middle of this to the middle of this whole subsequence, right? So basically you have to move this to here. That means you have to move this, the left-hand side of this distance, the right-hand side of this distance, right? So you want to move this thing all the way to kind of like here, okay? So you move 2 times of the distance of the middle of your pair to the middle of the subsequence, okay? So let's assume those edge. So if we just look at the edge, okay? Let's assume those edge at the position 1, position 2, all the way to position K. Okay, let's say we have K of them. Let's say we have K of them, right? So obviously, if you look at this is I swan. Let's say this is I swan from I's edge, P of K, right? P of I swan. So you have to match. Which one you have to match? You have to match Pi to K. Obviously, you have to match K minus I plus 1, right? So that's the one you need to match. Right? Let me switch the clock. Let me just make it easier to write for a second. So this one and this one need to match, right? So it means P and I need to match P of K minus I plus 1, right? So on the left-hand side is the I swan. On the right-hand side is I swan, right? So the amount of movement is, let's call this a movement m, function of m, right? So if you think about the movement, two things, the I swan and the J swan, right? That is, let's say the middle, right? The middle, we talk about this middle, right? Let's say the middle is big M, okay? Let's say the whole length is L, so it's L plus 1 divided by 2, right? So that's the middle. So you have to move a middle minus P of I plus M minus P of J, right? So actually, sorry, other way around. P of J minus M, and because J is here, I is here. It actually has to be like take absolute value. Okay. So you have to move that much. Okay. It's actually did I write it correct? If I have I, actually, I mean, it should be M minus P of I minus P of J minus M. So that actually should be like this. So it is 2 of M minus P of I minus P of J, right? So for that case, then let's look at all the things, right? So we have to look at all the if I this is for a length of one of the lengths, right? So if you look at it, if you look at all the ones, then the one of so you have to do sigma. I has to go from 1 to k divided by 2, right? We take the lower bound, of course, as this function I of k minus I plus 1, right? So, but you have to consider a case that, let's say if both G and H are odd, then there's no way you can do this, right? Because if both G and H are odd, you have to put one H in the middle. Then, but if you want to make G palindrome, you also have to put G in the middle, and you cannot do that. So that means there is another term, which is it has to be if K has not to be, K cannot be odd, right? So in the even case, then you have to move this center edge. Let's say you have three of them, right? You have to move one of them to the one left in the center and not paired to the center, right? So is K plus 1 divided by 2, the center one, you have to move to the middle, right? You have to move that one to the middle as well. Okay, so that is the whole thing, right? That is a whole calculation we need to do. Okay, so let's see, how do we calculate this? We said this has to be O n squared log n, right? So we cannot calculate this in O(n) time. Otherwise, it's going to be O(n) cubed, right? So this term, let's look at this term first. Anything that is -1 and 2 not k and is odd, that's easy, right? That can be done by O(n) squared term. That can be solved easily. So that term can be resolved. So then we just have to calculate this term, basically. We just have to calculate this term. Okay. Let's call this term function f. Okay. So then the question is, we have the previously, right? So we have P of I, there's 2H, right? One is at P of I, another is at P of J. Okay, let's calculate this way. What is this sequence, right? What is this sequence that include P of I and P of J? There is a sequence, right? Let's say this sequence on the left-hand side is left, on the right-hand side is right. If we just calculate all the sequence that cover P and I and P and J, but it does not reach P of I minus 1 and does not reach P of J plus 1. If you do a sum for each of this, right, P and I and P and J, each of this, that is, there's O(n) squared of those, right? We do the sum for all the L left and right, that is from P of I, but not reach P of I minus 1, to P of J, but not reach P of J plus 1. If we do the sum this way, in other words, if we do the sum of left and right, that belongs to this region. P of I minus 1 to P of I to P of J to P of J minus 1, but not include P of J. If we do a sum like this, right, as we said earlier, we're not going to jump H, right? So we do sum of this. If we do sum in this, in log n complexity, then we can solve this easily, right? Then we can solve this. If the problem for this is this, look at this, right? Mij function. It has a absolute value, right? If it doesn't have absolute, that's very easy to do, right? It's just do it. That's easy. But it has absolute value. So then here is the issue of this for this absolute value, right? So let me for easy. So let me write it down here. Of m of ij is absolute value of 2m minus pi plus pj absolute value, right? So remember we said we need to move the center from here to here, right? The center of here is m, right? Center of here is pi plus pj divided by 2. We need to move it twice. We need to, this has to move it, this has to move. So we'll have to move this distance twice, right? So this is 2 times of m minus pi plus pj over 2, right? So that's what we mentioned a little bit earlier. So we need to do the sum over the whole thing. This, remember, we talked about this in the bit, right? Simple segment tree, right? Bit discussion before, right? For those kind of binary stuff. Think about it. If m is bigger than pi plus pj over 2, if that is the case, right? Every time you change, if m increase, this mij function, so this is positive, right? So increase. If m is less than pi plus pj over 2, so this mij function becomes 2 times of pi plus pj over 2 minus m, right? If m increase, this thing decrease, right? So it's basically a split it, right? Depends on your bigger or less, right? On this side is an increase function. On this side is a decreasing function. And we talked about that before, right? When we talk about bit, you can just use bit to do this sum every time update, right? So if you can't remember what that is, go back, look at our previous class notes, right? So use bit is a standard, this is a standard trick to do this sum over absolute value. So then this update can be done by log n, right? So you sum up over a binary tree, right? So this can be done by log n. So then the total is n square log n, right? So you have n square of those pairs. Each pair you take a log n to calculate. Because basically another way to say it is every time you update, you move the left and right, right? It's log n update, right? Every time you change it, it's log n update. So if you exactly calculate it, is we can make this as a homework, okay? So if you have total is n, right? Inside n, you have g of g's, and you have h of that, right? Basically g plus h equal n, right? You can calculate, there is basically h squared over 2 plus n squared over 2 of this bit calculation. Okay. So that is still works for n equals 7,500. There is actually another trick which can slightly improve the complexity, but it's not necessary. I mean, improve the speed, but not necessary to pass this, because we just choose the edge, right? In this case, I mean, there's no reason we have to choose edge. We can choose G. In fact, we can choose whichever is smaller. If G is smaller, we use G for this calculation in each of the sequence. If H is smaller, we use H for this calculation. It can be proven that the most that you need to do is 5/8 of n squared of bit calculation. It can be proven that. So I'll make that as a homework for you guys to prove that. Then there is another thing to say. There is a way to make it of O(n) squared instead of O(n) squared log n using bit. The reason is if you look at when you move this Pi and the Pj, if you look at the movement, it's actually one directional. So for example, if you move this way, your middle of this will only increase, right? If you move this way, the middle of this will only decrease. If you single pointedly change the segment and using a pointer to identify where the movement is, you, instead of using bit for log n, you can do that update in O1. I'll leave that as a homework if you want to do that. But I leave that as a homework for you guys to, if you're interested. You can pause this by doing this, a slight improvement and more improvement. So that's the solution for palindrome. It's take a little bit of math to do this, and please go back and visit how we do the sum on the binary on the absolute value using bits in one of our previous class. So and the homework is I really would like you guys to try to solve it in a O(n) squared approach using the pointers, because it's the change of this m function is one directional. So this is the third problem. So we talked about those three problems, and the next competition is by end of this month, which is you have like 2 more weekends to prepare until the next one come up. So finish this homework, and good luck with your January competition.